Hello folks, so in this video I wanted to talk about why the properties of logarithms make sense, and I wanted us to really compare them to the properties of exponents. And they should look familiar or similar because remember that a logarithm is just an exponent written in kind of a little more esoteric way. So here are our properties of exponents here on the left side, and to get to the properties of logarithms we just need to really know the definition of what a logarithm is. And so what I'm going to say here is I'm just going to keep this in the corner here so we don't forget, but the definition of a logarithm is just, again, that log base b of x, say, well, we'll change up the letters a little bit just so we don't get confused. We use log base k of j is equal to, say, L. And again, this is the exact same equation as this, just written differently. K to the L is equal to J. Okay, so we remember the definition of a logarithm, so we'll save that there. Now I'm also going to rely on this fact right here, is that I'm just going to say that x to the a is equal to, I'm going to call it big A. So x to the a is something, and then likewise x to the b is equal to something. Call that b. Okay, I realize now I could have just used this, so let's just erase this. And we're going to use these and keep these in our toolkit. Save these in the corner here. And again, from here, we can see our equivalent logarithmic equations. Well, the top one would say log base x of big A is equal to little a, right there. And log base x of big B is equal to little b. Sorry, that's a little small, but hopefully we can see that there. Okay, so let's start off with our first property, where if we multiply two powers with the same base, the end result is to just keep the same base and add the exponents. So what I'm going to do is just perform a little bit of substitution here. So let's see. I'm going to substitute x to the a power with just big A here. It's some number, right? So right here, x to the a is some number a. So what I'm saying here is when you multiply these, what we'll call kind of the final answers, the results of the exponentiation, your final answer is just going to have the same base, but again, the exponents have just been added. All right, nothing too crazy here. Again, just a little bit of a substitution. But we can rewrite this equation now because it's in an exponential form, right? We still have x to some power is equal to some final answer on the right side. Sorry, on the left side. Excuse me. So if I rewrite this equation in its logarithmic form, we're going to get this. Log base x, because again the base is x right there, and the final answer, the argument of this, if I work it backwards, is AB. And that, well, that would be equal to the exponent right here, A plus B. Right? So all I did so far is I just substituted the result of x to the a in for x to the a, and same thing for b to get this b on the left side. And I rewrote it in its logarithmic form. So now I end up with this, which looks kind of, well, doesn't look like what we're used to seeing, but remember that I have these two equations in the corner here. And so if I do some substituting back in, we end up with the properties of logarithms that we saw before, or we saw in class. And this says that log base x of this product, AB, is equal to log base x of A plus log base x of B. Sorry, that should be, oops, big B right there. So again, this property, there's a little proof here that shows that, sorry, it's a little cramped, but that shows us that if you want to evaluate the logarithm of some product, then you just factor it out into two numbers and evaluate the logs separately and add them. Now this again should make sense because let's think about what this says. This says, sorry, the property of exponents come back over here. It says if you multiply the final answers together, you just add the exponents that it took to get there. And so what happens here? Well, in this property, again, you had the final answers, quote unquote final answers, the final results of the exponentiation multiplied together. And what do we do? Well, remember, these are the exponents. Log base x of a, this value is the exponent needed to, excuse me, it's the power you need to raise x by to get to a, big A. And likewise for log b. So again, this property of logarithms, log of a product, is the exact same thing as the properties of exponents, the power of a product. Again, with the same base. It's important to remember the same base. We can follow the same procedure, or a very similar procedure, with the logarithm, to prove the logarithm of a difference property. And so again, we'll substitute. We'll get x to, so we have x to the a on top divided by x to the b. So we'll say big A divided by big B is equal to, well, we know the result of this using our exponent properties is supposed to be a minus b. And so if we evaluate now, or sorry, if we rewrite with our exponential, rewrite our exponential equation into its logarithmic form, we'll say log base x of a over b is equal to the exponent a minus b. But once again, we know that a and b are given in this equation in the top right corner. And so we're left with log of this quotient, a over b, is equal to log base x of a minus log base x of b. Again, this should look familiar because what happened? Well, I took the results of the exponentiation and I divided them, so that's where this comes in. And then what do I do with the exponents in that case? Well, I subtract the exponents, which is exactly what happened here. So maybe I should actually do this in a different color. We'll use purple, and we'll do the same thing here. This part corresponds to this part. This part corresponds to this. And the gold part corresponds to this piece. The last property is a little bit funky. Again, we can do a similar process here. So we have x to the a, and c is just some other constant, some other number here. So x to the a, again, that's equal to a, so we'll just substitute that in. To the c is equal to, and I know the result of this is to multiply whatever a was with c, and that's the new exponent, the new power. But once again, we can rewrite our equation from its exponential form into its logarithmic form. We'll get x to the, log base x of a to the c power is equal to a times c. That's a little funky, but this is not too bad because we know what little a is once again. We know that little a is right here in the top right corner. Top right corner. So we can just substitute right here, and we can say that log base x of a to the c is equal to, and I'm going to reorder this, put the c in front, c times log base x of a. So once again, if we take the final result of x to the little a and raise that to the c power, that's exactly what this piece is. Then what do we do with the exponents? Well, we just multiply that exponent a with the new one, c. So hopefully this video helped kind of demystify why the properties of logarithms are the way they are. Again, they're really just the properties of exponents kind of rewritten using our new log perspective. Alrighty? So hopefully that was interesting and helpful, and I'll see you in the next video.